Well, we're going to talk weighted averages today. So I find that weighted averages can often elude people, sadly, and they can be kind of hard to get your head wrapped around. And so one of the things I would like to talk about today is just relating this idea of weighted averages back to an idea of a simple average, but then using it to help understand a couple of basic techniques that are good on the tests in general, not just on weighted averages. So my big primary goals today are to, and by the way, we'll be pulling from our second edition 5-pound book. And the question numbers will all be listed, so you can find them primarily in our weighted averages chapter in that book. But we're going to work on weighted averages. We're going to focus primarily on visual solutions. So something it's like near and dear to my heart for the GRE in general is this need to be scrappy, that your job is not to do math, but to try and get questions right by whatever means that takes. And so often I find that like your traditional math isn't the fastest or most intuitive way to get to an answer. So tonight we're going to work on maybe getting a little more comfortable drawing pictures and seeing things visually. And my hope is that not only can you use that on weighted averages, but then you can use that on other questions. Maybe you think a little past the equation. We are then going to have a focus in on QC problems, because at the heart, QC, quantitative comparison, is really a compare, don't calculate type of problem. And weighted averages highlight that really nicely, that instead of doing a ton of work, you can just use your understanding of weights to compare the two columns, compare the two quantities. Nice. Well, all right, we're going to get started. Let's talk just briefly about a basic average. I'm going to have you guys help me out. Let's say, right, I have one person and they got an 80 on their test. And I have one person over here and they got 100 on their test. What is the average grade for the two people taking this test? What's their average grade? Yeah, right? Pretty easy. It's right in the center. Right? And the reason is because I just got one of each. And so a simple average here would be a 90. All right, what if I change my story a little bit? All right, so here's my guys with 80 points and here's my guys with 100 points. What if I now have 12 people that got an 80 and 12 people that get 100? What happens now? What is the average? And you can break out the calculator if you want. But what is the average now going to be of these two groups? And when you think you know what it is, go ahead and type it in the chat window. So Nadra's message, I want to hear from the rest of you guys. Do you guys agree, disagree, still solving? Let me know. Olinka, you raised your hand. Did you? Okay, so I've got a question on the window, like how would I calculate this? So let's think about that. You've got 12 people who each score 80 points on a test. Right. Then you got another 12 people who score 100 points on the same test. Right. I'm going to put them all together and I'm going to find the average. So somebody help me out. What is the formula for the average of any average, right? How do I find an average? How do I find just a simple average? Yeah, so my simple average formula is going to be the sum of everything divided by the number of terms. So in our original example, the average when we had one person who got an 80 and one person who had 100, right? We had one person here, so two people total. That would have been 180 over 2, which is 90. We can also think of the average as being exactly halfway between them. Exactly halfway between these two. So what changes then when I have 12 people? How do I calculate my sum when I have 12 people? So I got 12 people getting an 80 and 12 people getting 100. How do I calculate that? What changes? Nice, 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 you guys. So instead of a sum just being an 80 and 100, right? So I'll sort of, actually, I'll tuck this over here. This was my original. Slide it over here, just out of the way, just so we can compare it to the one we're going to do. My new average is going to be the 12 people times the 80 plus the 12 people times their 100, right? Because I could add it up 100 plus 100 plus 100 plus 12 times, or I multiply. And then I'm going to divide it by the total of 24 people. And then when I do that, I've got, what, 960 plus 1200 divided by the 24. And then what do you get when you finally run that through your calculator? What does that kick out to be? What spits out? Huh, it's 90 again. All right. Let's try one more. One more. Let's imagine instead of 12 people, I'll pick a little easier number to do the math with. Let's say there are 7 people who get 80s and 7 people who get 100s. Now what is the average of those 14 people? What is their average? The average of these 14 people. And how would I calculate it? Yeah, and what? Let's see. How many of you guys actually did the math on that one? Okay. Give me a thumbs up if you did the actual math, if you multiplied it out and checked it in your calculator to confirm it. Cool. Yeah, right. And so in this case, we've got the average is equal to 7 times the 80 plus 7 times the 100, all over 14. Now, rather than multiply it out like I did over here, I'm going to do something that we could have done with this example. Notice that both terms in the numerator have a 7 in them. So I'm going to kind of separate that out. And this is going to be 80 plus 100 divided by 14. All I did was factor out a 7. And now that 7 that we factored out can actually cancel with this 14. And lo and behold, notice that the average is still the same in terms of the calculation. And the same would have been true if we had done that here, factored instead of multiplying it out. We could have factored out the 12 from the numerator, left this 80 plus 100 in there. That would have canceled with our 24 and would have once again been 80 plus 100 over 2. So we started with what seems like a basic average. I got one person who gets an 80, one person who gets 100. But as we make this narrative a little more complicated, we still keep getting the same answer. We still keep getting the same answer. And that's because all averages, all of them, are technically weighted averages. The weight just tells us how much or how many times we should be counting a certain number. And what's really important in weighted averages isn't the actual number, but it's the relative weight. And maybe a way to think about it is the ratio. So in a simple average of 2 numbers, you've got a ratio of 1 to 1. I've got one person getting an 80 and one person getting 100. Whereas in these higher versions of it, you still get a 1-to-1 ratio. It was 12 people getting 100, or 12 people getting an 80 and 12 people getting an 100, or 7 people getting an 80 and 7 people getting 100. In all of these cases, be it 1-to-1 or 12-to-12 or 7-to-7, it's the same ratio, it reduces down to that same 1-to-1 ratio. And so when I have weights, so is it 7 people? Is it 12 people? Is it just one person? When I have these weights that come out to 1-to-1, it's nothing more than a simple average. Nothing more than a simple average. And if we think about it, so a lot of times we'll talk about this idea of a teeter-totter. Like you'll see that sometimes show up, it's certainly in our curriculum, but you'll see it show up in other places. And I'm here to offer you a different visual. I like the teeter-totter, and there's plenty of places where you can go out and find it. I'm just going to offer you another one in case that one, it doesn't always sort of click. I like what I call the tug of war. So give me a +1 in the window if you are familiar with the game Tug of War. You got like a rope and you got the 2 teams, right? And you're like pulling in opposite directions. So Pia says yes. Yeah, cool. All right, so here's the idea. Is if I have, so back to my little basic kind of game here. If I have a rope strung between these 2 sides, and I have one person standing on this side of the rope and exactly that same person standing on the other side of the rope, and they're both pulling in their own direction, then the flag is going to stay right in the middle because they have equal tension on the rope. And so that flag is not going to move at all, which means the average when the 2 sides are equal is going to be dead in the center. And it doesn't matter if I have 1 person on each side or 3 million people on each side. As long as there's an equal pull, then that average is going to sit right in the middle. So what happens then when all of a sudden this guy over here at the 100 points goes and grabs a bunch of friends and now has, 10 people over here? Like, what happens when we have 10 people sitting down here? Does the flag stay in the middle anymore? No, that's right. The average is going to go up, right? Like even just logic would tell us like there are 10 more people on this end pulling in that direction. And so what we're going to end up having is this little flag is going to head way this way. In fact, we can actually think about it like a pull. That this team, the team 100 points, has 10 times as much power as the 80-point team. We are no longer in a ratio of 1-to-1, we're in a ratio of 1-to-10 or 10-to-1, whichever way you look at it. Yeah. So our 100-point team is really powerful at this point. Extremely powerful. Now, here comes my favorite aspect of this tug of war game. This little tug of war game. So I'm going to pick a number that's going to make this a little bit easier. So I'm going to swap these out because I want you to be able to calculate it relatively easily as well. So let's imagine we've got 2 people on this end, and we've got 8 people. Actually, no, we'll go a little simpler. We'll say we got 1 person down here, and I got 4 people up here. So our 100-point crew is 4 times as powerful as our 80-point crew. Now we know that if the actual average, if it was dead in the center, would have started at 90. But I have more people sitting over here, and so it's going to drag the average that direction. Right? In fact, what we can think about is any move that comes this direction, all of this space is credited to this team because this team is able to keep it that far away from their opponent. They're pulling and pulling and pulling. The only thing, right, that's going to keep them from winning. Right? So help me out. What is it? What is the force? So what is this? Who gets credit for this distance? Who's doing this work right here to keep the flag from crossing over this threshold? Who's doing that work? Yeah, the little team, right? So our big team is doing the work to pull the flag this far away, this distance. And our little team is doing the work to keep the flag away from the winners by this littler distance. So essentially, we're looking at each person or each team responsible for the distance on the other side of the flag. That's how far they've pulled it in their own direction. Nice. So May put in the window 96. So I want to actually compute this number because we've been given all the inputs. Let's calculate it. So our standard average here, right, or plugging it in, we've got one person who gets an 80, and we've got 4 people who get the 100 for a total of 5 people. If I do that math, I've got 80 plus 400 all over 5. And then I've got another 480 over 5. And then throw that in your calculator, divide it, you get a 96. So this average number, we were right, it was going to be way closer to 100. This average number is at 96. But I want you to notice something. Okay, so we know the math works, we plugged it in. So if we count this purple arrow, right, as the work that our bigger team, yeah, the one person on this end and the 5 people on this end, yeah, for my sum, right, because my total, right, so sum divided by the total number that would be these guys. So now I want you to notice something. Our big team, our 100-point team who has 4 people, have pulled that average 16 points. Whereas the little one-man team has only pulled the average 4 points. What do you notice about the relationship between those? What might stand out to you? It's still a 4-to-1 ratio. In fact, our bigger team, our 4-man team, has been able to pull the average 4 times as far as our little team. 4 times as far as our little team. So this is how a weighted average actually works, is that the weights tell us the proportion of work in this like tug of war game. So if I've got 4 times as many people or 4 times as many occurrences, I'm going to pull the average 4 times as far away. Let's imagine then, right, I'm going to change these numbers. And let's say, right, we'll go back to all this jazz again. We'll clear them up out of the way. So I'm going to say now that there are 3 people on this end and 12 people on this end. What's the average going to be? What's my new average going to be? And anybody want to explain why it's the same? What do you think? Why is my average going to be the exact same again? It's the same ratio. Right? So it doesn't actually matter what my specific weights are. In fact, it doesn't matter at all. What matters is the ratio of them. And so if I know that now this ratio, I always sort of reduce it. This ratio is really not a 3 to 12, but 1 to 4 again. I can then, without having to go down to my formula, I can say, all right, here's this distance, a 20-point difference. It's a range, right? We have this 20-point range. I've got 1 person over here. They've got 4 people over here. This guy over here is going to do 4 units of work, like 1, 2, 3. I don't have to be perfect. I'm just going to put the number somewhere. And I didn't do that terribly well. I did that actually really poorly. So let me get my 90 out of the way. So I can, my one guy over here will do 1 unit of work his direction. My 4 unit guy is going to do 4 units. 1, 2, 3, 4 units his direction. And so the actual average is going to sit right here at the point that is 1 unit pulled towards the one-man team and 4 units pulled towards the 4-man team. I got 20 points. I can just kind of think like a number line. Where would each of these lines be? And over the course of 20 points, it'd be, you know, like 4, 8, 12, 16 to 20. Yep. So there would be my little number. So this would be 84, 88, 92. So I'm counting them up from 80 to 100 to 96 to 100. There's my perfect intervals of 84, 88, 92, 96. And I can show that that's where my average would be. Now here's the deal. When you're given sort of all the endpoints and you're asked to solve for the average, a lot of times it really is just going to be easier to throw it into this weighted average formula. And the formal weighted average formula is the weight of whatever the first thing is times that number plus the weight of whatever the second thing is times that number. So the 1 times the 80 and the 4 times 100. You then divide it by the total weight. But understanding this ratio combined with multiple choice answers can make it really easy to estimate your way to a right answer almost immediately. So this is what we're going to try. We're going to take this idea of understanding that a ratio pulls right in one direction or the other by trying out some problems. And so we're going to do one more on this little silly example that I have right here. Let me get this guy out of the way. So now let's imagine that instead of the ratio the way it currently is, a 1 to 4 ratio, what if we had instead a 4 to 1 ratio? Let me get these guys out of the way. Now let's say that our team down on this end has a 4, and our team down on this end has 1 person. Rough estimate. Is my average going to be more to the left or more to the right? Definitely more to the left, right? Because there are 4 times as many people on this end as there are on this one. So whatever this distance is, if this distance is, 1, this distance is going to be 4. So you could plug it in and solve. You could start to make some estimations to get you there. You could see this as a ratio of 1 part belongs to these guys, 4 parts belong to these guys. That would mean that there are technically 5 total parts, 1 in one direction, 4 in the other. And at a 20-point range, each one of those parts, well, there's 5 parts, each one would be, divvy up that range, it'd be 4 points on my scale. So if this is an 80, this would be an 84. And I didn't draw this terribly well, but then this would be 88 and 92 and 96 and 100. And so my average this time, and feel free to check it with the formula, my average this time, it better show up as an 84. Definitely more to the left. If you were to plug it in, 4 times 80 plus 1 times 100, all over these 5 people, I have my 320 plus 100 divided by 5. I've got 420 over 5. And so there's my 84. So minimum, think about a benchmark. Think about recognizing how far. Even better than that, you can start to get a sense of exactly how far, and maybe not to that level of precision, but at 4 times closer to one than the other, that can give you a much better sense than if, let's say, the ratios were, let's say there were 3, oh, here we go. We'll say there's 7 people on this end and 6 people on this end, where's the average going to be? So I got 7 people who got 80 points. I got 6 people who got 100 points. Where's my average going to be? Left, right, dead in the center? A lot of the way to the left, a lot of the way to the right. Nice, R. So if they were perfectly even, 7 and 7 or 6 and 6 would be right in the middle. So it won't be right in the middle because they're not equal. It's going to be just to the left a little bit because there's just that one extra person. It's not, they don't have that many more people. They just have the one. And so they will have edged the flag a little bit in their direction, but nothing so drastic as some of the examples we've seen already. Okay, so let's try one in a more realistic, right? A more realistic situation. So let's give this one a try. And I'll give you, 2 minutes to kind of poke at it. Maybe you plug it in, maybe you do both. You try to sketch it out and take an estimate and then plug it in. That'd be my recommendation. And if you'd like to put your answers maybe privately, just to panelists, that'd be great. I also want to know how good of a job you did estimating here, if you got pretty close. All right. All right. So we've got a couple of options here, but I'd like to start with the visual. How many of you guys tried? I got a couple people told me about how they estimated, but give me like a thumbs up or a hand raise, or just, let me know if you were at least made an attempt at estimating. I'd like to see. Okay. So if I draw my picture out, I have 5 books on this end with an average price of $12. And I've got 1 book on this end with an average price of $18. Now my exact middle is going to be halfway between the two. And so the halfway point between these two is, I could solve it by a simple average, or I could count, right? So if I've got 6 between them, 12 to 18 would be 6, and the midpoint's going to be 3 from each side. So the midpoint will be 15. You can also calculate that by taking a simple average of 18 plus 12 over 2, or 30 over 2. Now here's what we know. We know it cannot be the simple average because there are 5 times as many cheap books. And there are 5 times as many cheap books. And so it's going to pull that average in its direction. So what I know is it's not going to be E. I also know that this is, whatever this actual spot's going to be, this little flag is going to land 5 times closer to 12 than it is to 18. And so I had people say that they were estimating like 13 and a half or even 14. What I'd say is, sure, you could plug it in. You could take, 5 times 12 plus 1 times 18 and divide that whole thing by 6. What I'd like to see you try is like, well, let's pick one. I personally saw it and thought, oh, I don't know, 14's a little close to the middle. Like if this is 15, then 14's right here, and that certainly does not seem 5 times closer. So I went to the next even number and said, let's go 13, right? So 13 be kind of like in here. And I said, well, how far is 13 from this end? It's $5 from that end. And it's only $1 from this end, which is the exact pairing I'm looking for. I want it to be 5 times further from 18 because there are 5 times as many of the little guy. And 13 works, and so I'm going to pick it. If this still wasn't far enough, I'd pick 1250. If it had gone too far, I'd probably pick 1350. So at a minimum, you should have been able to get rid of answer choice E. That when we have uneven weights, the answer will never be the exact middle. But if you want to get precise, you can use the answer choices. You can let them give you a sort of lead. All right, so now we get to where there's a little bit more funny business, where the GRE can sometimes get a little bit more meh with us. And it's where they don't give us real numbers. And they're leaving out some stuff. So I'm going to give you the same. I'm going to give you 215 on this one, but I really want to encourage you to try sketching it out. You're welcome to try the algebra. I'll just warn you up front. Might be a little nicer with the picture. Good luck. All right. I got a few people saying they sketched it out. I'm kind of a little bit curious because I've got everybody down to one of 2 answers. And folks who got in early all said B, and folks who started coming in later all said D. Okay, so let's look at our options. The average height of women in this sample was 66 inches. And the average height of men in this sample was 72 inches. The overall average was 70 inches. Is that the middle? Is the middle 70 inches? No, right? Like the middle is not 70 inches. It's closer to which side, the right or the left? Closer to the right side. Yeah, closer to the right side. So over here is, if we were kind of like, 66 to 72, if I wanted to draw this to scale, right, there's like 8 tick marks between, or 6 tick marks rather, between these. So like 1, 2, 3, 4, 5. So 67, 68, 69, 70, 71. Oops, I missed. I had one too many. One middle. There we go. So 67, 68, 69, 70, 71, 72, right? So if I were going to draw it like a little number line. So 70 is actually right here. That means that there are more what? Men or women? More men or women? There are more men. Yep. So if there are more men in the sample, if I'm looking for the ratio of women to men, and there are more men, right? This number is going to be bigger, whatever sits there. What answer choices can I get rid of? What can I get rid of? Yeah, ACE. Anything where women were equal or larger. So A is out, C is out, E is out, right? I have more men. Now let's look for the ratio. It is 4 units towards men, and it is 2 units towards women. That means that this is a ratio of 2 to 4, which reduces to what? Yeah, this is our ratio of 1 to 2. So I want somebody to and go ahead and send it to me privately. A good number of people pick 2 to 3. So I want you to tell me where you did the count, right? So I want you to think about it. Like, where was it that you found 2 to 3? Was it a miscount? Was it a different thing that you compared? Have you guys type it up for me? I got one that was, oh, so I got one person calculate the ratio of 4 to 6, which would be men as a fraction of the whole. So if you got this by saying, 4 out of 6, this means that 4/6 of the group would be men. That is true. And then 2 out of every 6 people would be women. So 1 to 3. But the ratio of women to men is 1 to 2. The distance from one end relative to the distance from the other. Oh, got it. Got it. Didn't count them. Yeah, missed those 2 numbers. Yep. And so you have to count all the way across. Okay. Let's try. I'm going to try this one. It does. It can help with the visualization for sure. I want to know, yeah, we'll try and solve this. This one's a little messier. This one's getting a little, actually, no. I'll give you one that's maybe, let's try one first. Let's try this one. We're going to give it as a fraction, but I want you guys to just think about finding the visual of this. this kind of relationship. All right, I got some great comments like, oh my gosh, I'd have to skip this one. This one's so confusing. We're still going to sketch it out, right? Let's sketch it out just, let's sketch out just for a moment, just so you can kind of see. Also, sometimes sketching it out will make it easier to do the actual algebra if you feel like doing the formula. So if we've got 2 radios per person, and there's 6,000 people down here, and then you've got 4 radios per person, and you've got 10,000 people down here. The middle would be 3 radios, which we know we don't have. We don't have exactly 3 radios because, well, 1, they're asking for a fraction, but 2, there's not an equal number. But we know now that weighted averages don't really care about the number of people in each town so much as the ratio of people in each town. So do I really have to say 6,000 and 10,000? Could I like simplify that a little bit instead of running around with 6,000 and 10,000? What easier numbers could I use? Yeah, I can make this 6 to 10, or take it down even further. This is really just a ratio of 3 to 5. Just a ratio of 3 to 5. Now at this point, if you're like, oh my gosh, these aren't going to be clean numbers, and I don't know how to draw a number line because like it's 3 parts, 2 radio, it's 5 parts with these 4 radios, which means 8 parts total. I would have to divide this number line up into 8 little tick marks, because that's what we end up, because I need to bring it 3 units that way, and I need to bring it 5 units that way. And so if you're like, oh, this is tough and I don't want to fill in and I don't know how to do it, then great, don't. You also, though, at this moment, could have seen this in a problem with multiple choice answers, which means you would know that the correct answer had to be bigger than 3 and a little bit smaller than 4, right? Like somewhere in that range. Yeah. And so you could do it as just the weighted average, though, right? What's my weighted average? It's the number down here. So I have 3 people with 2 radios each. And over here, I have 5 people with 4 radios each, for a total of 8 people. So I've got 6 plus 20 over 8, 26 over 8. Divide those both in half, 13 over 4. Just be careful with the math. And then you'd have to write it as a fraction, so you would just write it as 13 over 4. But I just want you to think about, all right, if I had to draw this timeline out, how would I compare these two quantities? Could I use the answer choices to let me play this, like, process of elimination a little bit? So what I really want to get this to is one of my favorite things, which is QC. Because the rule of QC is to compare, not calculate. And so often weighted average problems have like a story and a really complicated quantity, and then one quantity is just this really simple value. And so rather than try and compute all this information, can I just compare this to this one number? So I want you to take a look for a moment, right? Like, I want you to sketch out the picture and see what they're asking for. But then before you actually compute this average, I just want you to compare it with quantity B. And now if you haven't done a lot of QC, our choices are A, if quantity A is always bigger, B, if quantity B is always bigger, C, if they're equal, D, if you can't tell. So quantity A is always bigger, quantity B is always bigger, they're always equal, or you can't tell. We'll take about a minute and a half on this one. All right, so we've got a weighted average. We've got 118 people with one type of score, 100 people with a different kind of score. So I got 118 down here. I've got 100 seniors over here. My juniors have an 88 score. My seniors have 92 score. If there were an equal number of juniors and seniors, what would the average final score for all of them combined be? Right, so we always go back to that place like, well, what if it were equal? Yeah, it'd be right in the middle. And right in the middle of an 88 and a 92 would be a 90. Weird that that's the number that's sitting there. But it isn't an equal number, right? Who's winning our tug of war? At least by a little. The juniors are winning our tug of war, which means it's going to pull the average their direction. And since it's pulling the average their direction, I don't have to calculate the actual average. Here's what I know, that the actual average is going to be somewhere between 88 and 90, which is going to make it less than 90. And so the quantity B is always bigger. And I can solve weighted average problems in QC with almost no time and no computation. Absolutely no computation. C equal would mean that they that the average of these lumpy groups has a simple average, and it wouldn't in this case. It's going to be closer to the juniors, at least by some amount, because the juniors are bigger. Let's try something similar, right? Very similar problem. Try it again. See what you think about this one. All right, so my page, there you go. There it is. So if we were to sketch it back out again, I've got 66,000 citizens with a salary of $55,000. I'm just going to call it 55 because I don't need these zeros running around in my money. So I'm going to call you $55. And the other end of my spectrum is $45. Let me count my numbers. I've got 66,000 people over here. I got 73,000 people over here. But I remember I really only care about the ratio. So I'm just going to call this 73 people and 66 people. So here's what I know. I know that the $45,000 paycheck folks are winning. There are more of them, not by a ton, but there are more of them. Now, if the actual average between 45 and 55 is 50, because that's halfway between the two, then the average of all the citizens together is going to be less than that. And so once again, it's quantity B. Here's the fun news, right? If you can get comfortable with this, you'll be amazed at how often you can apply this same idea to very different kinds of problems. So for example, we're not going to spend all the time to solve it, but I want you to, we will go through it, walk through it, but I want you to give this question a quick read. So in this scenario, we've got Davis driving in one direction at 50 miles an hour and coming back at 60 miles per hour. And we want the average speed. So there'd be this thought that like, well, if it's 50 there and 60 back, the average speed is obviously 55. However, the average of speeds isn't just a simple average, because speed isn't just a simple single variable. Speed involves both a distance and a time. And while the distances might be the same there and back, the times certainly wouldn't be. Which direction does Davis spend more time? In which direction does Davis spend more time? To work or back? Where does he spend more time? So we actually do. If the distances are the same, when you go slower, it takes longer, right? If I leave from my house and I drive to Fayetteville, right? And if I go at 50 miles an hour, it's going to take me a lot longer to get there than if I go 60 miles an hour, which means that over the course of that trip, I spend more time doing 50 miles an hour. And so the 50 miles an hour is going to have a bigger impact on my overall average speed, which I know sounds crazy, but it's the same weight. 50 miles an hour has a higher weight because I spend more time going that speed to cover the same distance, right? Like my distance is fixed here. So I'm spending way more time. And so here I'm spending less time. And so my average speed is going to be pulled down by how much time I have to spend doing 50 miles an hour, which means my average speed for the whole trip is going to be less than the midpoint. It will be less than 55. And the answer would be 8. So when you're looking at even rates, and when you think about the average rate, even there you can say, wait a minute, hold on. This isn't a standard average. This is like a weighted average because not all the pieces are exactly the same. Times aren't the same here. And so, yeah, I know. I think it's great too. And so that the average isn't going to be exactly the middle. If you're not sure from that point forward where to go, you can at least eliminate C in this case because you know it's not going to be the midpoint. And now you're down to like a 1 in 3 shot, and that's great odds. Oh my gosh, yes. I would absolutely classify this as a harder question because average speed is complicated and the formula is complicated. And for this, you'd have to like make up your own, like you'd have to kind of invent miles for distance so you can figure out how much time. And you could say, all right, let me build a story. Let's say the distance between the two. Let's find something that I could do 50 and 60. Let's say like 300 miles between the two. And so in the direction where I go 50 miles per hour, it's going to take me 6 hours to get there. And in the direction where I'm going 60 miles per hour, I guess Davis is going 60 miles per hour, it'll take him 5 hours to get back. The formula for average speed is total distance over the total time. Now I made up my distance. That's 300 out and then 300 back for 600. I have to also trust at this point that making up numbers was okay, right? Which isn't always. And so then I've got, all right, then total time would be 11 hours. Notice that when you divide 600 by 11, you are going to get 54.5, less than the average. Because I spend more time going this direction than this direction. My denominator, where I would normally add up my total, my sum, like 5 people in this group and 12 people in this group, I have more people. I have more being added in at the 50 mile an hour rate. And so it cuts my average speed. So definitely one of the harder ones. All right, you guys. So that's the story, right? Our story today is all about thinking about weighted average as a visual solution, right? Like as a visual solution, at a minimum, you can make some estimations. Yeah, agreed. I think the teeter-totter sometimes can be confusing, right? It works great for some and can be a little confusing for others. So I think sometimes that tug of war, right, works really nicely. And so just the one final reminder on your tug of war, right? Here's my 10 people here with a GPA of 80 points or whatever. And here's my 20 people here with their 100 points. What I want to think about is it's going to be closer, 2 parts closer actually to this guy. Going to pull it 2 parts. This guy will pull it 1 part. And so my average in this case would be not a pretty number, but 2/3 of the way across, or 1/3 of the way away from 100. But we're looking at that ratio. that this could really be seen as a ratio of 1 to 2. And the 2 guy has pulled it his direction by 2. And the 1 guy over here has only been able to pull it his direction by 1. Cool. All right, you guys. Have a wonderful rest of your evening. Have so much fun studying for the GRE. I know a few people may have popped in because I think we've got a GMAT study panel coming up shortly. But thank you guys so much. Good luck with your studies. I am excited to know that maybe you'll feel a little bit more comfortable with weighted averages. If you ever need us, by all means, right, come check us out in the forums. Come join us for a free trial class. Right, check out any of those free trial upcoming classes, any in-person or online complete course for free. Right, have a great night, guys. Take care.